Today I am going to explain about single phase AC circuit and average value for AC signal. First thing, what is meant by AC circuit? In DC circuit, the opposition to the flow of current is only resistance. It is the only resistance. But whereas in AC circuit, the opposition to the flow of current opposition to the flow of current is because of resistance, and also due to inductance and capacitance. Due to inductance, it is inductive reactance that is denoted with XL, which is given by in terms of inductance as 2 pi FL, and due to capacitance, it is given by capacitive reactance. It is given by denoted with XC, which is equal to 1 by 2 pi FC, where F is the frequency of the supply and C is the capacitance. So, that is the first point. In AC circuit, the opposition to the flow of current is not only due to resistance but also due to inductance and reactance. Due to inductance, that is inductive reactance, and due to capacitance, that is capacitive reactance. Next, what is meant by AC supply? What is meant by AC supply? AC supply means AC voltage or AC current. They are represented by magnitude and direction. We know that a DC current has only magnitude, but AC supply, it has both magnitude and direction. That's why it is mentioned as the AC voltages and currents are represented by magnitude as well as direction. We and also we know that I mentioned in my previous classes, the examples for AC supply are a sinusoidal signal, a trapezoidal signal, a triangular signal, the signal which varies continuously with respect to time. Okay, now here these alternating voltage and current may or may not be in phase with each other. The alternating voltage and current in the circuit, AC circuit, they may or may not be in phase with each other. Okay, they are in phase means the angle difference between voltage and current is zero. This is how in phase. Let us say this is a voltage and this is a current sinusoidal. The one is a voltage AC signal, sinusoidal signal, and the other one is current sinusoidal signal. They are in phase. This is for in phase example. That means there is no angle difference. If we take this is the angle on x-axis. On x-axis usually it may be time or angle. Okay, that is angle is nothing but theta, which is equal to omega t. This theta is equal to omega t. So this is how in phase voltage and current, and they are out of phase. Okay, they are not in phase means that is nothing but out of phase. Let me show. If it is a voltage signal, the current signal is behind. Let's say that here the angle difference is theta. This is the out of phase. Okay, first one is in phase and this is out of phase. Okay, so this is how here if you see the second picture, the current is behind voltage. Current wave is behind the voltage. So the terminology is current lagging voltage. Current lagging voltage. This happens usually in case of inductance. Whereas in case of capacitor, voltage lags. Okay, that means current is ahead, but voltage is behind. Voltage is behind the current. So that is in case of capacitance. So these two, the second one and third one shows the out of phase. Okay, and the first one is in phase. That is the meaning in phase and out of phase. So continue. Let's continue here. The alternating current and voltage may or may not be in phase with each other depending upon the various parameters of the circuit like resistance, inductance and capacitance. Yes. So that is what I already mentioned. So in case of resistance, the voltage and current are in phase. In case of inductance and capacitance, they are out of phase. That means they are not in phase. The sinusoidal alternating quantities, okay, here are voltage and current which varies according to the sign of the angle. So they are telling that they vary according to the sign of angle, that is sine theta. Okay, now general point, for the generation of electrical power in all over the world, the sinusoidal voltage and current are selected because of the following reasons. For the generation of electrical power all over the world, sine AC signal, they are telling sinusoidal voltage and current are selected. AC supply is okay, not DC, that is AC. Why? Because the reasons are, see that mentioned, they mentioned 3 points. The sinusoidal voltage and current produce low iron and copper losses in the various power system equipment, that is transformer and various machines are there, generators which are there in the power system. Okay, so they reduce the losses in all this equipment in the system, in the power system. So which means it improves the efficiency of the AC machine. It maintains the improves the efficiency. Second point, they offer less interference to the nearby communication system. Okay, less interference means uh, we can see in our street also, beside the power line there is a communication line also running, okay, on the towers. Beside the power line there is a communication line. So what happens is, this power line is operating at very high voltages, whereas communication lines are at low values of voltages and currents. So there is a this high operating power lines causes interference with the that neighboring communication line. So what they are telling is, with the supply, with the AC supply, that interference becomes less. That is the second. Then the last point, they also produce less disturbance in the electrical circuit. So these are the main reasons all over the world why they use the AC, not DC supply. So because of these main advantages of AC supply. Then, okay, basic definitions, okay, of single phase circuit, basic terminology we need to know before going into the system. So here the various terms frequently used in AC circuit are: first one, alternating voltage and current. What is meant by alternating current? So in the name itself, it is there actually we can understand directly. Alternating means it is continuously changing with respect to time. So they also say other way like this also, what it is shown here, the voltage that changes its polarity and magnitude at regular interval of time is called alternating voltage. Similarly, alternating current, the current that changes its polarity and magnitude at regular interval of time. Okay, then second definition, come to the second definition. What is meant by amplitude? or peak value. The maximum positive or negative value attained by the alternating quantity. If you take a sine wave, okay, if we take a sinusoidal signal, you can see I have taken like this. Here, the peak value, okay, it is defined as the maximum positive or negative value. See, this is a positive area of the signal. This is a negative area of the signal. So, if you look at the positive area, they are telling that the maximum positive value, or if you can take the peak value in the negative area also, that is the negative value. So if it is a voltage wave, I say that this is a positive plus Vm, and negative area maximum value is minus Vm. So peak value, it is defined as maximum positive or negative value attained by the alternating quantity, okay, in one complete cycle. So here actually cycle means this is called cycle. This is a cycle. Okay, I come to that later. Also, cycle means one set of positive and negative values attained by the signal. So here, coming back to the definition, we are talking about. I'm talking about peak value. Okay, it is nothing but the maximum positive value or negative negative value, maximum negative value attained by the alternating quantity in one cycle, one complete cycle, is called peak value. The other name for it is maximum value or amplitude. Okay, it is denoted with, see that it is denoted with Vm. Okay, if it is a voltage signal, Vm. If it is a current signal, Im. Okay, so voltage signal, sometimes they also say that Em, capital Em. Vm or Em if it is a voltage signal. So that is a peak value or maximum value. Next definition, we have alternation. One half cycle. Just now we have seen, okay. Okay, so this is a cycle. So one half cycle, it is called as alternation. And span, electrical degrees, okay, this is 0 means this is 90 and this is 180. Okay, then it is 360. One cycle means 360 degrees, half cycle means 180 degrees. Next, cycle. When one set of positive and negative values completes by the alternating quantity. So, remember, cycle definition is a one set of positive and negative values attained by the AC signal. It is said to be 360 degrees electrical. Okay, in terms of angle. Okay, now instantaneous value. Instantaneous value, in the name itself it is there. The value of voltage or current at any instant of time. In the name itself it is there. At any instant of time, the value of voltage or current is called instantaneous value. It is denoted by small I. It is denoted by, if it is a current signal, small I. If it is a voltage signal, small e or v, small v also. Next, frequency, the number of cycles made per second by the alternating quantity. Frequency means number of cycles per second. It is measured in cycle per second or hertz. It is measured in cycles per second or hertz. Okay, and it is denoted with the letter F. Denoted with the letter F. Next definition, time period. Next definition, time period. The time taken in seconds by voltage or current to complete one cycle. So this is one cycle, right? So the telling time taken to complete one cycle, okay, in seconds. Time taken in seconds to complete one cycle is called time period. It is denoted with letter capital T. Time period denoted with letter capital T, and the relation between time period and frequency is given by T is equal to 1 by frequency, or frequency is equal to 1 by capital T. Next, waveform. Waveform. What is meant by waveform? So here what I have drawn, it is a waveform. Okay, a definition. How can we say that as a definition? The shape obtained by plotting the instantaneous values of alternating quantity. So these are the different instantaneous values, right? Different timings. So the shape obtained by plotting instantaneous values of alternating quantities such as voltage and current along y-axis. Yes or no? This is voltage or current. And time on voltage or current along y-axis, time or angle on x-axis. Okay, so that is called waveform. Now, peak to peak value. Peak to peak value. The peak to peak value of sine wave is a value from the positive to negative peak. Okay, so it is a value from positive to negative peak. So what is a positive peak? This is a positive peak, Vm, and negative peak, minus Vm. So this is peak to peak value. Value from positive peak to negative peak. So from plus Vm to minus Vm. Okay, so it is given by peak to peak value is given by 2 Vm. 2 times of the peak value. Next, these are the examples for different alternating signals. So it's sinusoidal signal, a square wave, a triangular wave, a sawtooth wave. Okay, and here also they have first one is sine wave, next is sine squared wave, then square wave, pulse wave, sawtooth wave, half wave, rectified wave. Okay, so this is also comes under different AC signal. Now, average value. For an AC signal, how to find the average value? So, if an AC signal is there, that may be a AC voltage or AC current signal, how to find, okay, to calculate its value, there is a value called average value, and also other one, okay, that is there in it will be in next lecture, that is RMS value. Okay, first about the average value. How they calculate the average value of this AC signal. Here see that first thing, the average voltage indicates, okay, they are talking about a voltage signal. It indicates average of instantaneous voltage. Instantaneous voltages that are chosen at appropriately timed intervals in the half cycle of the wave. Average of the instantaneous value voltages that are chosen appropriately timed intervals. Okay, appropriately, that instantaneous values are taken appropriately timed intervals over the half cycle. Okay, half cycle of the wave. That wave may be a sinusoidal, triangular, trapezoidal, or any other shape. Okay, so first thing, that is the first thing. Average of the instantaneous values at appropriate time intervals over the half cycle. Now, what happens if we take full cycle, for complete full cycle? If average is found over a complete cycle, its value will be 0. The average value will be 0 for both sinusoidal and non-sinusoidal waveforms, provided the wave is symmetrical. If the wave is symmetrical wave, the average value is always calculated for a half cycle. Now, what is meant by symmetrical wave? If it has equal areas of positive and negative values, okay, if it has equal areas of both positive and negative, then that is a symmetrical. Okay, if doesn't, they are not the same, then that is called asymmetrical wave, unsymmetrical wave. Example, I can say like this. Okay, so this is asymmetrical wave. See, if it has only positive cycle, so this is asymmetrical wave, and this is symmetrical wave. So if it has equal areas of both positive and negative, then that is symmetrical wave. It doesn't have, then that is asymmetrical wave. So the point is, if the wave is a symmetrical wave, the average value is calculated only for half cycle. If the wave is not a symmetrical wave, average value is found for complete cycle. Okay. Now, average value is also known as DC value. Okay, average value is also known as DC. See that the average value, okay, it is repeating, the point is repeating. The average value of voltage is the average of all instantaneous values during half cycle. They are actually DC values. Now, the average value is the amount of voltage that would be indicated by a DC voltmeter if it is connected across a load. So, if we connect a DC voltmeter in the circuit, what it measures? It measures the average value. Now, look at this last point, instantaneous voltage. Okay, we know that instantaneous voltage is denoted with small e or small v. Okay, V is equal to maximum voltage into sine theta. Maximum voltage into sine theta. What is the maximum voltage? Peak voltage, and multiplied with sine theta. So that is the basic relation. Instantaneous voltage is equal to maximum value into multiplied with sine of the angle. If it is a current, I is equal to Im sine theta. I is equal to Im sine theta. That is how an AC signal is represented. Okay. Here Em is a maximum value of the, if it is a voltage signal. Okay. Em is the maximum value, its maximum value, and sine theta, angle of the sine. And if it is a current signal, small I is equal to maximum value of current Im into sine theta. Next, how to calculate? So now it is known that what is meant by average value. Now how it is calculated? How it is calculated for an AC signal? First method, there are two methods. First method, mid-ordinate method. Mid-ordinate method. So mid-ordinate method, in this, the average value of alternating wave can be determined graphically by taking arithmetic mean of ordinates at equal intervals over a half cycle. It is determined arithmetically with mid-ordinate method. It is determined graphically by taking the arithmetic mean of ordinates at equal intervals over a half cycle. You can see here in the picture, here it is half cycle is shown with the instantaneous values. Okay, so at equal intervals, here at equal intervals the voltages are V1, V2, V3 and so on up to V12 it is shown. And here okay, the wave is divided into n equal parts, let us say, with the instantaneous voltages during the intervals being V1, V2 and so on Vn. Okay. Now, the average value of the voltage in figure. Okay, V average is equal to V1 plus V2 plus and so on Vn by n. Yes, so that is what it is defined. It is determined graphically by taking the arithmetic mean of the ordinates. So that's why V average is equal to V1 plus V2 plus Vn and so on Vn divided by n. Next method, analytical method. So this is the most commonly used method to determine the average value for any AC signal. So for the average value for a periodic function, given function is f of t and period is capital T, then it is given by f average is equal to 1 by t capital T period into integral of 0 to t. T is a given period, integral of f of t dt. F of t is a given function. So in this method, analytical method, the average, to find the average value, this is a main expression to remember. Okay, 1 by given period, 1 by t into integral of 0 to given period into given function. Okay, let's do for a sinusoidal voltage. Let us consider a sinusoidal voltage. Okay, so how a sinusoidal voltage signal is taken? Previously you know that, right? So E is equal to, small e is equal to maximum value multiplied with sine theta. So now let's see, if you calculate average value, you know that sinusoidal signal is a symmetrical signal. So if you calculate the average value for a complete cycle, let's see, already we know that for a symmetrical its value will be 0. Let's see that once. Do for full cycle now first. So E average is equal to 1 by capital T. What complete cycle means? What is the time period? 2 pi. So 2 pi integral of 0 to 2 pi Em sine theta. So substitute here. Okay, take this out. Em by 2 pi integral of 0 to 2 pi sine theta. So Em by 2 pi integral of sine theta is minus cos theta. So substitute the limits. Cos 2 pi is plus 1 and cos 0 is 1. So 1 minus 1 0. So its value will be 0. So that is what average value of a sinusoidal signal for a complete cycle. Its value is 0. Now do it for half cycle. So we know that, okay, we get some value. Let's see, calculate and see. Average value of voltage over half cycle. So half cycle means what is the time period? Pi. So 1 by pi into integral of 0 to pi Em sine theta. Take Em out, Em by pi integral of sine theta. So we know that integral of sine theta is minus cos theta. So minus cos theta Em by pi minus cos theta 0 to pi Em by pi minus of cos pi is minus 1 and so minus 1, so minus 2 multiplied with again minus, it becomes 2 Em by pi. So that is the average value of sinusoidal signal over a voltage over a half cycle. So that is about average value. Okay. of an AC signal, how it is calculated. So there are two methods. First one is mid-ordinate method. Second one is an analytical method. So this is an analytical method which is the most commonly used one. So based on this, the problems also there. So they give a signal waveform and they ask to calculate the average value. So based on the given waveform signal, we have to calculate the average value by looking at the waveform. First, we have to identify its symmetrical or unsymmetrical wave. Based on that, take the time period. This time period, you have to decide this time period. Okay, then given function, this one. Okay, so that is how we need to calculate the average value of an AC signal. So that's all for now. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.